All right, here we go. We're looking at the review for test unit 8, angles and circles, arc length and area of sectors. So we look at the first problem. We have to find the radius, diameter, or circumference based on what's given. Number 1, we are given the radius, which is 9.5. Our diameter is 2 times our radius, so our diameter here is 19 feet. Then our circumference is pi times diameter, so that's 19 pi feet. Leave it with the pi, give exact answers. For number 2, this time we have the diameter is 26, so the radius would be 26 divided by 2, so that's 13 centimeters. And then our circumference is either 2 times pi times our radius or pi times diameter. So our circumference is 26 pi centimeters. This time we're given the circumference. So that means this is pi times diameter. So to get our diameter, do 97.5 divided by pi, and we get 31.035 inches. So then to get our radius, divide that in half, so we get 15.517 inches. Next one, we again have our circumference. However, this time we have the pi. So this is just pi times diameter, so our diameter is 3/4 inches. For the radius, we divide 3/4 by 2, and we get 3/8 inches. We continue on. Looking at circle E, we want to name the circle. Remember, we name a point by its center point. So that is circle E. To name a radius of the circle, we need to go from the end edge of our circle to the center. So an example would be ED. You would also have EC and EF. All those are examples of your radius. You only need one. I'm giving you all 3. Chord is just a line that hits 2 spots on your circle, so this would be either AB or CD. And then diameter has to go through the center point and hit the circle twice, so this would be line CD. So then we get into our angles and arcs. All right, so we're looking for the measure of ADE, means we start at A, have to go around to point D and stop at point E. Well, we know that the line, this would be 180 degrees, and then here's 90. So this would be 180 plus 90. So ADE is 270 degrees. For AD is just from point A to point D. Well, since this is a right angle, we know this is a right angle, so AE would be 90 degrees. And since CE also has to be 90 degrees, and this part's 65, then DE is 25 degrees. Correct. Yes, so that makes AD 90 plus 25, so that's 115 degrees. Because we're all central angles here, so everything's equal. The last one here is arc DCE. We start at point D, go through point C, continue around to point E. So it's everything except for arc DE. Everything except this arc in blue, and we already know that that's 25 degrees. So DCE would be 360 minus 25 to give us a total of 335 degrees. Number 7, we have some vertical angles here. Vertical, vertical, so we set those 2 equal to each other. Solve for x. So we get x is 10, so we plug it in. 3 times 10 plus 12. So we have this part's 42. Just double check that it's equal. 60 minus 18. It's also 42. So angle ZPV is 42 degrees, and angle YPW is also 42 degrees. So then if we look at the next angle, I'm going to outline in purple, ZPY. What makes a line with either of the 42-degree angles? So 180 minus 42, and we get 138 degrees. So both of these are 138 degrees. This time we were just dealing with the angles in our circle. So that's it. The next page. This time we have arcs. Remember the relationship between our central angle and our arcs. First we need to solve for x. Right here we have the line, so we know that 2x plus x plus 12 has to equal 180 degrees. So we solve for x. We get x equals 56, so we plug it in. 2 times 56 is 112. And then 56 plus 12 is 68 degrees. So, and we're going to use those to figure out our arc measures. UY. Well, we know this angle is 68 degrees, so UY is 68 degrees. With WP, this right here. Okay, so let's look. We know that this angle and this angle are congruent to each other. So we look, it's vertical from the 112 degrees, so both of these angles would be 112 divided by 2. So these are both 56 degrees. I'm going to erase some of this to make it a little bit less confusing. We should already have all of this written down. If you didn't, go back and rewrite it. I'm going to fill in all the pieces we do know. And just to finish it up, this would also be 68 because it's vertical from the other 68 degrees. Now we know all the pieces of our circle. All right, so W, U, Y. We start at W, go through point U, and end at point Y. So we add all those up together. 68 plus 68 plus 112 gives us 248 degrees. P, V, Y. Start at point P, go through point V, end at point Y. So it's everything but the 56. 350 minus 56, we get 304 degrees. WV is this part right here, so that's 68 degrees because that's the central angle measure. PY is this part here, so that's 56 degrees because the central angle is 56 degrees. Number 9, we have a quadrilateral inscribed in the circle, so we know our opposite angles are supplementary. So let's look at what we have. We have the measure of arc ABC is 300. So this arc right here is 300 degrees. So now we have an inscribed angle, because here's the inscribed angle that makes that intercepted arc. Inscribed angle is half of that. So angle CDA is half of 300, so this is 150 degrees. And we are looking for this angle I have marked off in red. Well, we know those angles have to be supplementary, so that angle needs to be 180 minus 150. So we get angle ABC has to equal, not 60 degrees, has to equal 30 degrees. Number 10, over here on the bottom, we know that ABO, this right here, is 35 degrees. Well, let's see. We're looking for this angle here, well, if we look at this triangle, we know these are both congruent because they're both radii of our circle. So that means our base angles are congruent, which means that CBA is also going to be 35 degrees. Number 11, we have BD is tangent to circle O at point C. So that means the line hits the circle at point C. We know that ECD, angle ECD right here, is 26 degrees. Well, this is an inscribed angle, so that means that arc CE has a measure of 26 times 2, which is 52 degrees. And then we're looking for CAE, which is what I've marked off in yellow. It's everything but that 52 degrees. So 360 minus 52, and that's 308 degrees. There's our answer. All right, number 12. Another quadrilateral inscribed in our circle. Let's look at what we need. For angle X, there's our angle. It's an inscribed angle. Its intercepted arc is the 72 degrees. So X is 72 divided by 2, so X is 36 degrees. Angle Y, this angle right here, it's an inscribed angle whose intercepted arc is that one. So angle Y is also going to be 36 degrees. So then we look at angle W, which is what I have marked off here in green. It makes this arc. Well, if we notice, the green arc makes 180 is half the circle with the 72. So the green would be 180 minus 72, so this is going to be 108 degrees. And angle W would be 108 divided by 2, so W is 54 degrees. And there's number 12. Number 13, let's see what we have. I'm going to look at this part right here first. We have a central angle, so angle Y, or for arc, so arc Y has a measure of 71 degrees. If I look at X, now we have an inscribed angle, so X is 71 divided by 2, which is 35.5 degrees. All right, so we look at number 14. If I look right at angle Z intercepted a semicircle, which means that Z is 180 divided by 2, so that's 90 degrees. And then I'm going to look at what else I have in this problem. I know over here that's not labeled intercepts a 32 degree arc, so that angle will be 32 divided by 2, which is 16 degrees. And then I know a triangle has to add up to 180 degrees. So if I look at angle X, it needs to be 19 plus 16, which is 106. Subtract that from 180, and I get 74 degrees. So X is 74. And then Y is the measure of its intercepted arc. So I do 74 times 2 and get 148 degrees for Y. Again, if I'm going a little fast for you, or you just need to slow it down and look at the problems again, just go back a little bit to the problem that you needed to look at. Number 15, for angle X, I have an inscribed angle who intercepts a 90 degree arc. So X would be 90 divided by 2. So I get the angle X is 45 degrees. For angle Y is the arc that intercepts a 30 degree angle. So angle Y would be 30 times 2, which is 60 degrees. right, if I look at number 16, I need to figure out angle x, or arc x. It's intersected by a 60-degree angle, so x would be 60 times 2, so x is 120 degrees. And then y is the rest of the circle. I know x is 120, and then I have the 60 degrees, so I have 120 plus 60 is 180. Well, it's half the circle, and y is the rest of it, so y would also have to be 180 degrees. If I look at number 18, which is the one up here. So here's number 18, it's just not numbered, things went a little bonkers. My vertex of my angle is outside of the circle, so I have to do my big arc minus my little arc divided by 2. So here's my big arc outlined in purple. Here's my little arc outlined in yellow. I have to do the big arc minus the little arc divided by 2. So I get 118 divided by 2, which is 59 degrees. So x is 59 degrees. Number 19. It's the same type of problem, but this time we're missing one of the arcs. Here's our big arc, so we're going to do x minus, here's our little arc. Divide that by 2. I'm going to rewrite this. X minus 80 divided by 2 has to equal 22 degrees. We need to get the x by itself, so multiply both sides by 2 first. Cancels out. X minus 80 equals 44. Add the 80. So x equals 124 degrees. Number 20. Right here. Okay, so I have a lot of the pieces of my circle, but I don't have the little piece. I have the big piece, which is 94, minus, I need to figure out the little piece, which is this part. That little piece is going to be 122 plus 78 plus 94, and that is 294 degrees. Subtract that from 360. So this part here is 66 degrees. Then I have 94 minus 66 divided by 2, and this gives me 14 degrees. 21, I'm going to cross off 18 because that one's the one up top. This one's number 21. Again, I'm working backwards. The 190 is my big arc, 190 minus the x, which is my little arc. Divide that by 2, and it has to equal 31. Multiply both sides by 2. This side it cancels out. Subtract the 190. I get negative x equals negative 128. Divide by negative 1. So x is a positive 128 degrees. Number 22, this time my vertex is inside my circle. So I take the 2 arcs that are made by that angle. In our case, we have the 49 degrees and the x. Add them and divide by 2, and that'll equal my angle. So 49 plus x divided by 2 equals 39. Multiply both sides by 2. 49 plus x equals 78. And I get x is 29 degrees. All right, so let's keep going. Constructions. All right, to construct our equilateral triangle, first thing we want to do is construct our diameter. Draw a diameter in. I'm going to adjust a little bit so it actually is our diameter, just hits our circle. There we go. There is our diameter. I need my compass. I want to put my compass point on the center of my circle, measure out my radius. Bring it down a little bit so I can rotate. All right, so I've measured out my radius. And I'm going to move my compass to the edge of my circle, somewhere on my edge of my circle, and draw an arc that hits my circle twice. Here, all I need to do is find where my arc intersects my circle, and then the top of the diameter, using your ruler. There's your equilateral triangle. I'm going to drag my compass down so I can do the next construction also. This one's a little bit more involved, but it's still not as bad as what we've done before. Not that bad. All right, so I want to construct the perpendicular bisector of one of my sides to start off with. So I need to make it more than halfway. Draw an arc. Do it from the other side also. Hopefully I got this more than halfway. Nope, I was nowhere close to more than halfway. So try again. All right. Let's make it more than halfway. I draw my arc. Then I have to do it from this end to two. I bring my page down a little bit more so I can actually see where they intersect. Just need to finish this arc. There we go. So my bisector is right there. There's a perpendicular bisector for the bottom. Now I need to go and do the same construction on one of my other sides. To make it more than halfway. Draw an arc. I don't believe that's more than halfway. Draw my arc. And I have to go over and do it up on the other side also. Oh Lord, this is so big. All right, so make it even bigger. All right, now it should be more than halfway, so let's just draw our arc. Flip it around. Yes, this time it's more than our arc. Good. Then, a perpendicular bisector is that line right there. And you continue my red one so it actually intersects my other line. Put my compass where my two lines intersect. It's okay that it's outside of the circle. I bring this down, I have to make sure this hits my vertice, and since it does, my line is just a little bit off, which is why my top point did not hit. Yours would hit perfectly using your ruler. All right, no more constructions. Yay. All right, so number 25, our vertex is inside of the circle, so we know we need to do the two arcs that make the angle, add them together, divide by 2. So we get x is 37 degrees. 26. All right, let's see. We have this central angle, which means we know this bottom part is 163. So then the top part, the other part that makes the angle, would be 360 minus 163, which is 197. Then we do 197 minus 163, and that is 54. Divide that in half. We get, wait. Once again, my math is wrong. Sorry. This is 34 divided by 2. So x is 17 degrees. 27. Got a lot of parts 27 here. So we're going to look at each part as we go. let's look at what we know first. We know that this arc right here is 130 degrees. Which means this angle is 130 degrees. And then that makes this angle right here, its supplementary angle, 50 degrees. So arc ST is going to be 50 degrees because it's intercepted by that 50-degree central angle. So then angle SOA is also 50 degrees because we just found that. You also could have done that since this was 130. Also could have done, since RS was 130 and ST was the rest of it to make the 180, 180 minus 130 is 50. SAR. Well, outside the circle, we know that's big arc minus the little arc, so 130 divided by 50, and that's 80. Divide that in half, we get 40 degrees. FMR. I'm going to outline this in yellow. FMR. That's this inscribed angle. So just divide the 125 by 2. We get 62.5 degrees. All right, I'm going to erase some of the circle to make it less confusing. MAR. First, we need to find the measure of arc MT. Since it makes a half circle with the 125 degrees, this is just 180 minus 125. So say 55 degrees. So then the angle would be 125 minus 55 divided by 2. And that gives us 70 divided by 2, which is 35. So MAR is 35 degrees. And then we're looking for MRA. Let's see what we have here. I'm going to outline this one in yellow again. MRA, it's the inscribed angle whose intercepted arc is the 55. So divide that by 2. This is 55 divided by 2, so this is 27.5 degrees. Back up top to number 28. Number 28, we have this 150 degree arc. We're trying to figure out the measure of this angle. Well, that angle is a central angle, so angle X is 150 degrees. 29, we have this 150 degree angle, or arc. Here's our angle we're looking for. That is an inscribed angle. So X would be 150 divided by 2, which is 75 degrees. 30, we again have the 150 degree angle, or arc. Excuse me, I keep saying angle. X is this angle right here. Vertex is outside the circle. So we know we're going to be doing the big one minus the little one. The little one is y. Divide that by 2 and it equals x. I'm going to simplify that a little bit. And then it's going to be more of a figure out which answers work. I'm going to multiply by 2. So I know that 150 minus y is going to need to be 2x. Well, let's see. If I plug in 25 here, 125, and none of my answers for x are 125 divided by 2. So I know 25 is not my answer for y. If I check 100, and I get 50, divide that in half, I would get that x is 25. So there's my answers. X is 25, y is 100. Kind of a checking. Y couldn't be 200 or 300 because then you'd end up with a negative answer for x. Next page. Number 31, we have to find the length of the arc. Remember, our formula is arc length equals our central angle divided by 360. And since we're looking for arc length, we're looking for part of the outside of the circle. So we're multiplying by our circumference, 2 pi r. Plug it in. We know our central angle is 90 degrees. Divide that by 360 times 2 pi. Our radius is 8. Simplify this a little bit. So we have 1/4 times 16 pi, so that's 16 pi over 4. So our answer here is 4 pi, and then make sure we include our units. So our answer is 4 pi inches. 31, or 32. We have two pieces here. First part is we have to find the length of this arc. Our central angle is 120. Divide that by 360 times 2 pi times 36. Well, 120 divided by 360 is 1/3, so this is 1/3 times 72 pi over 1. And then 72 pi divided by 2, or 3 is 24 pi, and then our units are centimeters. So then for ACB, we go the other way around. This time our angle would be 360 minus the 120, so our angle is 240. So 240 over 360 times 2 pi times 36. 240 over 360 is 2/3 times 72 pi. So this would be 144 pi divided by 3, which gives us 48 pi centimeters. Yes. Use your calculator for that one. Another arc length problem. Our angle is 60. Divide that by 360 times 2 pi times our radius, which is 15. 60 over 360 is 1/6 times 30 pi. So then our answer is 5 pi feet. 34. This time it's one of the backwards ones. Our arc length is 2 pi feet. Our diameter is 12, so our radius would be 6. We're looking for the central angle. So x over 360 times 2 pi times 6. Do some of this math and get 12 pi x over 360 equals 2 pi. I'm going to simplify this a little bit. 12 divided by 360 is 1/30. And pi x times 2 pi. Multiply both sides by 30. I get 60 pi equals pi times x, divide by pi. So x is 60 degrees. Wait, I am wrong. Hold on. So yes, so number 34 is 60 degrees. Going up, number 35. Again, backwards one. So our arc length is 5 pi. Equals our measure of our arc is 120, so we have 120 over 360 times 2 pi r. We know that 120 over 360 is just 1/3 times 2 pi r. I'm going to bring this up. So 5 pi equals 2 pi r over 3. Multiply both sides by 3. I get 15 pi equals 2 pi r. Divide by everything that's not your radius. And you get r equals 7.5 feet. There's your radius. Number 36, area. Our area formula for a sector is similar to our arc length. We still have the area equals our central over 360. This time we're multiplying by the area of the circle, which is pi r squared. So the area of our sector equals 90 over 360 times pi times 18 squared. So this is 1/4 pi and then 18 squared is 324. So I get 324 divided by 4. So my answer is 81 pi. And since we don't have any units in the problem, we don't need any units in our answer. So this time, we know that this piece is 60 degrees, but we're looking for this part. This would be 120 because it makes the line with the 60 degrees. So that means our area of our sector is 120 divided by 360 times pi times 26 squared. So this is 1/3 times pi times 676. So our answer is 676 pi over 3 as a decimal. That would be 707.905. All right, number 38. Again, we have the angle of the unshaded part, but we want the shaded, so we want all of this piece. Since the angle we do know is 60, our central angle is 300. So we have 300 divided by 360 times pi times 20 squared. 300 divided by 360 as a fraction is 5/6 times pi times 400. 400 times 6. 400 times 5. So this is 2,000 pi over 6, which simplifies to 1,000 pi over 3. And if we plug that whole thing into the calculator, we get that our area is 1,047.197. Again, no units, so we don't need them in our answer. Next one, we have the diameter, which means our radius is 13. And since it's half the circle, our central angle is 180. We can just automatically write that as 1/2 though, because we know it's half the circle, times pi times 13 squared. So we get 169 pi over 2, which would be 265.464. I would take either answer. If you were in Ms. Raggiani's class, I prefer with the pi. I want the exact. All right, so now we have a circle within a circle. We're given that AB is 7 centimeters, BC is 10 centimeters. We want to find the area of the whole big circle and the area of the entire little circle. We'll look at the big circle, then our radius is this whole thing. So this would be pi times 17 squared. So our area is 289 pi. For our little circle, our area is 7 squared pi. So that's 49 pi. And then just subtract the two. 289 pi minus 49 pi. So our area is 240 pi centimeters squared. This time we do need the units because we have units in the problem. Next page. 41. When you look, the center of the larger circle is point A. And segment AC is the radius of the larger circle and the diameter of the smaller. Okay, so I don't know what just happened there. So our big circle, we know the radius is 18. So the area of the big one would be 18 squared times pi inches. So this would be 18 squared, 324 pi inches. The little circle, Since our diameter is 18, our radius is 9. So we have 81 pi inches squared. Subtract the 2 to figure out the area of the shaded.